We rely on large language models for just about everything these days, right? Writing code, drafting emails, synthesizing complex research.
Oh, absolutely.
But here's the fundamental challenge facing these incredibly powerful digital brains.
Mm.
How does a system trained exclusively on static data from the past interact meaningfully with the real-time dynamic world?
Yeah, things that change by the second.
Exactly, like stock prices or, data that lives behind a secure API like your company's Jira board.
It's the ultimate scaling bottleneck for modern AI. I mean, they have truly vast, deep world knowledge, but that knowledge is instantly dated.
The moment it's trained.
The moment it's trained, it only updates when they undergo another massive multi-million-dollar retraining cycle. If you asked your LLM right now, without any external help, what is the current status of my highest priority bug ticket?
Or what's the latest Git commit on the main branch?
It would have absolutely no idea. It's trapped. It's in a version of the world that only existed when its training data was collected.
Right. And to build truly autonomous AI agents, the doers that can manage our workflows, check the weather, or run diagnostics, we need robust, standardized, and secure ways to feed in that dynamic real-time information.
We need reliable tool calling and R capabilities that don't, break the bank or introduce a ton of security vulnerabilities.
Yeah, exactly. But historically, connecting every single LLM let's call that M applications, to every external data service, API, or database, we'll call that N services.
Right.
It meant building an M by N mess of custom integrations. Every one of those connections required unique code for API access, unique auth schemes, unique error handlers.
Oh, and unique data format conversions. It was a fragmentation and maintenance nightmare.
I remember dealing with that headache 18 months ago. It was truly M by N misery. Developers were constantly just writing boilerplate code to shuttle data between the model and the actual tool.
So the search was on for a single standard to cut through all that complexity.
And that standard is the solution we are deep diving into today, the Model Context Protocol.
Or MCP. It's an open protocol designed specifically to allow systems to provide context and expose tools to AI models in a generalized, uniform manner.
So it replaces that custom, fragmented, and costly M by N system.
With something much, much simpler, an M+N system.
Which brings us to our analogy. Think of MCP as the universal adapter for AI agents.
It's really positioning itself as the USB-C of the AI world.
It is. Instead of needing 50 different proprietary connectors for your LLM to talk to GitHub, Stripe, and Postgres, you just need one standardized plug, the MCT. It just drastically reduces friction across the entire ecosystem.
So our mission today is to unpack this standard for you. We're going to look at the core architecture and the specific mechanics of the communication.
And explore the massive and rapidly growing ecosystem of specialized MCP servers that have popped up.
And fundamentally understand how this protocol tackles the non-negotiable enterprise requirements of security and true interoperability.
Okay, let's jump into the core mechanics. What exactly is an MCP server and how does it execute these digital tasks?
Okay, so at its heart, MCP is an open standard that emerged just before the end of 2024. Its stability comes from its foundation. It's built on JSON-RPC 2.0.
JSON-RPC 2.0. That might sound a little old school to some developers. Why that?
Well, it was a strategic choice. It's all about reliability and simplicity. JSON-RPC ensures that communications are purely request-response, highly predictable, and easy to parse, which is absolutely critical when the ultimate recipient is a language model that just thrives on structure.
Right, makes sense.
But what's fascinating here is that it takes successful concepts from the software dev world, specifically the Language Server Protocol, or LSP, and extends them.
But unlike LSP, which is usually reactive, right, it waits for you to type code.
Exactly. MCP is designed for proactive agentic workflows. This means the tools can actually drive the conversation forward based on what the agent's goal is.
To understand how this conversation happens, we need to nail down the terminology. There's kind of a cast of characters in this handshake.
There is. First, you have the host. This is the application where you, the user, are actually interacting. So think of sophisticated AI code editors like Cursor or maybe desktop app for Claude.
And inside the host, there's the MCP client.
Right, which is the library embedded locally. This client is important because it maintains a stateful session for each connection it opens with a server.
Okay, next up is the MCP server. This is the crucial intermediary, the wrapper.
It's a lightweight piece of software built right in front of the actual tool or data source or API. And then finally, you have the tool itself,
Which is just the underlying function, like the actual git pull command or a complex SQL query.
Exactly, the thing the AI model can ultimately invoke.
Now, let's walk through that core interaction using your example of running a git command. How does that flow work?
So it begins when the client calls a method, usually tools list, to the MCP server. It's basically asking, hey, I'm running a Git agent. What can you do for me right now?
And the server responds, I'm guessing, with some kind of structured data?
A structured JSON payload, yeah. It describes every tool it offers. It'll have the tool name, say, Git branch status, a quick summary, and the full JSON schema defining all the inputs and parameters.
The host then takes this list and injects that tool definition into the LLM's context, probably in the system prompt.
Almost always. So when you ask the query, what is the status of my current branch? That prompt triggers the LLM. It realizes it can't answer from memory.
And so it emits a structured tool call.
Right. The LLM says, I need to call the Git branch status tool, maybe with some arguments. That structured call goes back to the MCP client.
Which translates it into a precise MCP request for the server.
And here's where the abstraction really pays off.
Yeah.
The MCP server executes the underlying Git function, it handles the API keys or credentials, runs the operation, and then returns the structured result in a JSON response back to the client.
And the LLM agent never has to handle or even know about the secrets. That security layer is completely abstracted away by that server-client relationship.
It's a beautifully clean, secure, and repeatable loop.
And that modularity makes deployment incredibly flexible. Developers can build these servers in pretty much any programming language they want, right? Python, TypeScript, Go.
Java, whatever. As long as it can talk JSON-RPC, the requirement is minimal.
So how does that communication actually happen? What are the transport layers?
The most common one is Studio standard input-output. That's usually for local processes running side by side. But for true remote communication, which you need for cloud-hosted AI agents, MCP supports server-sent events, or SSE.
Why SSE? Why not just, standard HTTP polling?
Because SSE allows the server to continuously push updates and maintain that stateful session without the client having to constantly check in.
Ah, so for long-running processes like a database migration.
Exactly. The server can proactively send updates back to the client using that SSE channel, maintaining that crucial continuous context-rich interaction.
That flexibility and standardization, coupled with being language agnostic, has clearly created a massive surge in tools.
Oh, it has exploded.
Which brings us right to the ecosystem.
The reference implementations from the MCP steering group alone show the incredible range. You've got servers for general data access like everything, and fetch for web content.
Essential utilities like time.
Right. And deep functional servers for file system access, Git operations, and even memory servers that act like knowledge graphs.
And when you look at third-party offerings, especially in the enterprise space, the scale becomes immense. Official integrations exist for major developer tools.
We're talking Atlassian for Jira and Confluence, GitHub, Cloudflare, payment platforms like Stripe.
Major data platforms like PostgreSQL, MongoDB, Databricks.
Or even highly specialized servers that wrap AWS and Azure services.
Beyond the official enterprise tools, though, the community servers really show the breadth of what this protocol unlocks.
Totally. The barrier to entry is so low that people have quickly stood up servers for domains you might not have expected to be AI-enabled this fast.
Like what?
I mean, servers for blockchain platforms like Binance and Solana, gaming integrations for chess.com, browser automation with Playwright.
And even specialized data sources from government bodies like NASA or servers focused on niche fields like Brazilian law.
Yeah, that one's wild.
So that explosion of tools is great, but if anyone can build a server in any language, how does an agent or a developer find the right one? It sounds like a new kind of fragmentation, a discovery nightmare.
And that's the exact problem the Model Context Protocol Registry solved when it launched in September 2025.
The MCT registry.
Its whole purpose is to be the official, centralized, and open catalog and API for all publicly available MCP servers. It standardizes discoverability, moving beyond just simple keyword searches.
So this registry acts as the primary source of truth. And other public marketplaces, maybe integrated into IDEs or even private enterprise sub-registries, can build on top of it.
Precisely. It ensures everyone is looking at the same trusted list. And crucially, this centralization allows for community-driven moderation.
So they can deny list bad actors.
Right. The registry has a clear mechanism to deny list servers that violate guidelines. If a server has malicious code or tries to spam or violates licensing, it can be retroactively removed from public view. It enforces a baseline of trust.
Okay, so let's look at a practical application. The Cloudflare deployment guide excerpt in our sources is a great example of how simple this is for developers.
It is. The guide highlights the practical reality of deployment. Developers usually have two main paths on these serverless platforms.
Okay.
They can deploy a server without authentication, which is fine for public general tasks, or, more commonly, they deploy it with authentication and authorization.
Meaning the user has to sign in, and permissions control exactly which tools an agent can call.
Yep, which is key for enterprise security. The streamlining is massive. You get a live server, often at a workers.dev, a subdomain that any MCP client can connect to immediately. That reduction in friction is the core driver of adoption here.
That brings us to the most critical layer of all, security. Because while the functionality is robust, the sources highlight a pretty significant early limitation of the protocol that needed to be fixed.
It did. Let's talk about that early security hurdle. The early MCP implementations, so up until late 2024, early 2025, they just lacked a truly standardized, robust auth mechanism.
So it was this genius protocol, but it was hampered by a single point of failure, credential management. What did that look like in practice?
In practice, it meant that for secure operation, developers were often forced to run their servers locally alongside the client.
Which kind of defeats the purpose of cloud agents.
It totally does. Or they had to rely on manual, out-of-band provisioning of sensitive credentials like API keys directly to the remote server.
So if you wanted a cloud agent to securely access your GitHub repo, you had to manually upload your GitHub token to that server instance.
Yes, which simply does not scale for secure, remote, multi-user access in a SaaS environment. If you have 10,000 users who want to connect their individual credentials to a single shared agent, manual key handling becomes impossible and incredibly dangerous.
Right, so that problem was severely hindering MCP from reaching its internet-based multi-tenant potential.
Precisely. The solution, which was adopted really rapidly by the community, was integrating OAuth 2.0 as the secure, scalable standard for authorization.
And the adoption of OAuth 2.0 just changes the game entirely. It provides features we take for granted in modern web dev, like dynamic client registration.
And automatic endpoint discovery, which cuts down on configuration overhead.
But most importantly, it ensures secure authorization and token management.
That's the key. It means you, the user, authorize the agent once via OAuth, and the system guarantees that the MCP client can only access the specific resources you explicitly permitted within a defined scope using short-lived tokens.
This finally brings proper, modern security and compliance to cloud-hosted MCT agents.
It does. And this standardization is really the aha moment when you compare MCP to older approaches.
Like comparing it to building custom integrations from scratch. The benefit is obvious. MCP replaces all that manually written, brittle code with a single, reliable plug-and-play protocol.
And what about compared to the much-hyped ChatGPT plugins that we saw earlier in the AI wave?
Well, plugins were proprietary, they were tied to a single platform, and often they functioned as single-shot calls. You called the API, got an answer, and the interaction ended. There was no deep session context.
Whereas MCP, conversely, is an open standard. It fully supports those continuous, context-rich, two-way interactions through that stateful session.
And it now has that unified, secure OAuth standard. It's a fundamental architectural upgrade from those early proprietary plugin models.
Okay, so final comparison. Let's address existing LLM tool frameworks like LangChain. We know these frameworks let developers implement tools. What's the clear demarcation line between a framework and a protocol?
That's the most important distinction for our technical listeners. LangChain and similar frameworks provide a developer-facing standard for tool implementation. You define your tool logic in Python using their wrappers.
But MCP is a model-facing protocol that enables dynamic tool discovery at runtime.
So if I'm running an agent, that agent doesn't even need a compile time dependency on, say, the specific Postgres driver or the GitHub SDK.
Not at all. It just needs to know the location of a reliable MCP server that wraps those tools.
So an agent using MCP can literally discover and use a completely new tool like that one for Brazilian law data without the agent's core code needing to explicitly include it beforehand.
Exactly. It decouples the agent's logic and dependencies from the tool's availability and implementation. That is the definition of true scalable interoperability.
So what does this all mean for someone looking to build AI applications or just understand where the industries go?
It means the Model Context Protocol is the standard that successfully transitions AI assistants from being these siloed geniuses restricted by static knowledge
To becoming well-equipped, integrated engineers that can securely access and act upon the entire real world of data and external services.
Yeah. By standardizing that communication layer, it just reduces integration friction so dramatically and makes AI systems inherently more scalable across every single industry.
It sounds like the plumbing problem is largely solved. But the sources do hint at a potential roadblock still ahead, centered not on the tool communication, but on the LLM itself.
They do. Despite the massive success of MCP in standardizing the delivery of information, certain LLM limitations still exist. Today's models, they don't handle a huge number of available tools very well. Their reasoning can degrade when they're presented with too many options.
And critically, the results returned from APIs, even beautifully standardized JSON results, can still quickly overload the LLM's context window if they are too verbose.
That's a huge one.
This raises an important and I think provocative question for you, the developer, the entrepreneur, or the curious learner listening. Moving forward, must developers design APIs themselves to be truly AI native?
Meaning simplified, summarized, or highly curated data sets.
Exactly. Rather than simply exporting rigid legacy interfaces in order to maximize the full long-term potential of standardized protocols like MCP.
That transition from legacy interfaces to AI-optimized data endpoints, I think that's where the next era of innovation is likely to be found.